Hi, hello, and welcome to ESP, Introduction to Programming, week 3, I think, Alex, is that correct?
Week 3, I think. Yeah. Hi, also from my side. Hope you're fine.
Alex, how are you? You're at the Brown University again.
I'm good. I'm at the university, so not on a cold floor in the middle of Boston, Cambridge. And this is actually good to have a chair to sit on. So yeah.
Yeah, that's true.
I
Okay,
mean, it's
so
quite early here,
yes.
bit past 9. Yeah.
Oh, okay, yeah. Okay, so what are we talking about today? Um, Alex, maybe you want to share a few insights of today?
Sure, I would love to. Yeah, today we will delve a bit deeper into computational thinking. So, especially what we started last week, we talked about strategies to solve problems, and we will keep on with that. But today we will go a bit more into detail and will be a bit more technical. And this is kind of the last time when we were just on this concept layer next time. So after 2 weeks, because now we have 2 weeks break, we will really dive into the programming itself. And today we give you kind of the basics therefore, and then 2 weeks from now we will do the real cool tech stuff then.
Exactly. So yeah, very looking forward to that. Hope you too. The chat already some messages, so thank you for being there today again. I think it will be a very, very interesting um, lesson today.
By the way,
So,
quick
yeah,
question to the chat. In Studio, I realized that some, or at least one person wrote that they have some problems with ads in our videos, and we tried to figure that out. And actually, we deactivated all the ad stuff. So, do you get ads as well when you watch the videos, or watch it later on? Maybe just some quick message in the chat, so then we can figure that out, because we don't want that you get annoyed with ad actually. Okay. Yeah, I mean, same ad block. Okay.
yeah.
Good to know. I mean, I
Also an
also
ad
expected
blocker.
that because yeah. Yeah, okay. Just use an ad block. That's a good point there. All right. Yeah, thanks for the feedback.
Yeah, so we deactivated
Yeah.
all of the commercial stuff, but
Yeah.
we don't know. Maybe YouTube has some other rules behind which we cannot control.
Yeah. Yeah, we would love to make money because university is not paying that good. So we are highly we rely on the YouTube money actually, but we're not famous enough to do that. So yeah, however. Okay, I think now we can really
Okay.
start.
Yeah, we can start. We start again with a short organizational part, I think. So the coding session started this week, and you can register in the Teach Center. So this is only one block. The one block is only for October now, and you can only register once for one block. And in the next block, then for the November dates will be announced soon. So I think next week or at least 1 week before it starts. And if you have any questions, I gathered some questions and put it in an FAQ section on the course website where we can have a short look on it. So this is our FAQ website, and here we have some frequently asked questions. So if you have any questions, please read through them. And of course, if you have still some open questions, ask on us on Discord.
Sure.
Yeah. So then another organizational topic is the new lecture Vertiefung in die strukturierte Programmierung, which is an alternative to Design Your Own App, and more details you get on this link. Yesterday there was also a short introduction into our idea how we want to do it together with Daniel Cruz. And if you have any questions regarding this topic, again on our Discord server, there is a new channel, it's called this VSP, and there you can also get access to it at the roles section, and then you can ask their questions if you have any. And our last thing I want to share also now, but maybe also in the end of the day lecture, the next 2 weeks are public holiday in Austria, and so we have 2 weeks missing ESP, unfortunately missing, but it's also, or it should be, a good way for a good opportunity for you to learn, to use these weeks, and we have delivered also this voluntary coding exercises. Okay, I have to log in now, but you should be able to see it if you click on the link and you log in then. And here you can already start with the first three. I think the first three topics should be possible already to do, to try a little bit how C works. And of course, after the public holidays, we will give a short overview, or maybe not a short overview, extensive overview of all the topics we are talking now, or we were talking in the last week, and then put it into C context and show you how to write it in C. You're very busy in the chat, Alex. Are there any questions?
There was a wrong link. Julia mentioned that. I put the right link into it. VSP is not a STEO. VSP is the alternative to design your own app, actually.
Exactly.
Yeah. Then there was this question if you can do VSP if you already did design your own app. I think it's dreifach probably.
Mm.
I'm
Yeah,
not. I mean, it's
we
really
have to
meant to
discuss
be
it.
for design your own app,
Yeah.
actually. But I mean, if there's interest, we can find probably a solution because it will not make a huge difference. So yeah. In VSP, there will be no coding session. So the idea is you will get one assignment, and this assignment is a group assignment in groups of 3. You can pick your group members because this will also be probably a question. And then you have an assignment interview after that. This kind of prepares you already for OP1 because this is like the mode how OP1 will operate actually. You can also stay in design your own app, of course. It's just an alternative. You don't have to switch. It's just an alternative that we offer since some students mentioned that they want to have like a different way to go and whatever. And also due to the question of the waiting list, we will do this in the next days. This was really on short notice. So usually it takes a while until you can create the lecture or a course, and so it was really on very short notice within like 2 days.
Yeah, so some small or details are not quite clear even for us, so we have to define it and discuss it how we can do it. But we will announce it if news are ready for you to hear.
I mean, our course is not STEOP. Is designing on app STEOP, David? Do you know that? Probably, because
I don't know exactly.
these are the curricular things that we're not 100% sure. If designing on app is
But I think,
okay, thanks.
no,
Yeah,
I
it
think
is.
it is. I think it is. Yeah.
Okay, so in that case, it's kind of the alternative. So when you do design, when you do VSP, you get like you get design your own app actually. So yeah, then it's kind of stay up even though it's not stay up. I hope this makes sense.
So yeah, already 15 minutes gone.
Yeah.
That's always the organizational part. But I think we should now start
Yeah, we should
with
move on.
a recap what we have done last time. So last time we talked about data interpretation. and I showed you some random data. Let's say this is our memory, and we have here just binary values inside the memory, and this can have very different kinds of interpretation. For example, I can interpret these binary values as decimal values, which are then 255, 102, and 255. I can also interpret them as hex values, so 0xFF, 0x66, 0FF. And I could also interpret it as color, as we have seen last time. So these are the decimal or the values for the RGB color scheme. Um, then you get this very beautiful pink. And you could also interpret this data as CPU instruction, for example, which then could mean add two registers and write it into another register in this. So as you can see, the same data can be interpreted in so many ways, and it's important how you want to interpret it and not what the data is inside. Of course, what the data is important, but the meaning of it depends on how you want to interpret the data. Then also Alex showed us this flowchart diagram and have different representation inside the flowchart. We have these processes, conditionals, input and output, and the terminals. We will come to that in a few slides and show you the example from last time again, I think.
Yep.
Alex also showed us the organization of his bookshelf. Was it your bookshelf?
It was my bookshelf. No, it was not my bookshelf. It was a bookshelf. Actually, I think we
Okay.
generated that as well.
So we tried to sort the books there. We came up with the idea to sort it by color or the number of pages, the category, the author. And we also want to find the book, of course. How could we find it? Use the title, the popularity, and many more stuff. So this was already a first step. And today, I think we will get even deeper into this sorting and finding things, um, this algorithm thinking, and yeah, all this computational thinking, what we want to do now today. And yeah, this is also a flowchart from this very cool vending machine you created last time. And we have a start here. We then print a welcome output, set the input to 0. Then there's a payment selection option, pay by card or by cash. Then, depending on the payment method, you can scan your card or put the coins inside. And if the payment is successful or if you have input enough coins, then you get your drink and the output is thank you. So yeah, that was a short recap. And now we come to computational thinking in general. And computational thinking is divided into, let's say, 4 groups, Alex, is that correct?
Yes. We have kind of 4 different skills, a skill set basically. And we will go with you through all these skills today. The idea of computational thinking is that this is a set of skills that is not just for computer scientists. So actually, like the goal of school education in general should be to teach these skills, these computational thinking skills, like abstraction, decomposition, because this is like math or language, things that you should know when you interact with technology or if you work with technology, basically. And of course, as computer scientists, you should have a deeper understanding of that as like regular people that just work with computers or have a good technical understanding. And this is also a reason why we go a bit deeper today in these things. And we will cover a few topics. I mean, we could fill a whole entire lecture just with computational thinking, which we won't do, but we will fill this lecture unit today with it. And you will see, you will know many of these things already from your daily life or from your prior knowledge probably. So I would say let's start with the first one, which is abstraction, and just imagine what abstraction could be. So we have this picture here of an old man, and now we want to do some abstraction. And yeah, what could be the very basic abstraction of this old man? Let's see how this could look probably.
So this is a very, very basic abstraction.
It is. It is. So yeah, when you look at the picture of this old man, what would you say? What features do you need? Which can you like skip? What would you say? Head and body, yeah.
Head and body. Yeah, you
Beard
forgot the
is
beard.
missing, yeah, sure. Yeah, actually, these are also my kind of drawing skills, so the right ones.
Yeah, but with the beard, it would be identical. So no difference.
Yeah, and so the question is actually, what do we want to abstract? Yeah. If we just want to say in our representation, okay, this is human with a head, a body, and arms and legs, then we're fine. But depending on what do we need, yeah, what else do we need? What do we want to do with this? And this is what today is about. We will actually talk about different types of abstraction, and I have another abstraction. Let's go to the next abstraction. Um, we see here a super fancy computer. Um, let's break it down. Actually, what would a simple computer look like? So, question in the chat: what like basic ingredients do we need for a super very simple computer? And some of you may notice what I'm actually doing at the moment. Okay, CPU, GPU, RAM, storage.
By the way, is this AI generated? I think
Sure.
so. Yeah.
This is the way to go for me from now on. I generate everything like that. Yeah, let's go to the next slide probably, because last week we talked about this already. So like a very basic abstraction is this, the von Neumann architecture. And David had a good time explaining you last time what a computer actually consists of, and like the most basic ingredients: CPU, some kind of main memory or memory, and some input output devices. So this is actually the very easy representation of a computer. Yeah, let's go for another example. And I think a really good example to abstract information are maps. I have 3 maps of Austria, and we will just shortly go over these maps and try to analyze them. The first map that I brought with me is a political map. Just put in the chat, name a few things that come to your mind when you see like a political map of Austria. Mix it up with like politically in the sense of which parties there are. So it's not about the political system in Austria. It's like a political map that you would find in a borders of Bundesland. Yeah, borders. Yeah, countries, main city, rivers. All right. I think yeah, it's mainly that. It's the borders and the Bundesländer. Yeah, to Tyrol. That's right. Interesting map. Haven't realized that. Right. So, would you say this is a accurate representation of Austria? Actually, Yeah, that's the point. Yeah, so from the perspective of the political features that we need, it's accurate. It's all information that we need. Let's go to the next one and have a closer look on that. This is a physical map, and so we see the brown parts like the mountains, and green parts, all the flat parts, stuff like this. So this is a different representation of the same Austria, actually. So like when checking the map, it's like the same shape. We also have some the cities, we have the borders, but what else do we have? We have mountains, we have like the flat parts of Austria, the cities, the rivers, probably. So yeah, as I said, this is the physical representation of the same map. So it's more detailed, but on the other side, we need this probably in a physical map. So there's a different way how we abstract information, and in maps there is a lot of information. And David, next map, please. This is a completely different map. This is a weather map, actually. And this is, again, highly abstracted. And we just have some cities and the weather information in this city. So yeah, again, here we don't need some details that we probably have in other maps as well. And yeah, actually the question is, what features do really matter in the map? So maybe you can go to the next slide, David, and then a question in the chat. What features do all maps, all three maps that I showed you, share?
Oh, by the way, Alex, was this the weather map? Was this from today?
I just Googled yesterday weather map Austria, and that was the first result that I got. So it should be actually from today. Yeah, that's right. But I'm not sure if it's.
There's the date was today, but it's not raining in Graz.
Okay, that's good. So okay, what do they share? So at least we get some abstraction. The shape, that's right. Borders, Austria overall, border to other countries, cities. The cities, borders and cities. So I think this is, we all agree on that. All these maps share some common things. So this is like the shape, the neighbor cities, the neighbor countries, the cities, and I think that's it actually. And this is what we want to reach with abstraction. We want to build models later on, and we want to get all the information that is relevant in the context we're looking at something. And this is something, as a computer scientist, you will do this a lot. You will get a problem and then think about the features in this problem or related to that or in a data set, and try to make some first basic abstractions. So to make it a bit more understandable, I have a nice quote. Abstraction is the process of simplifying and hiding detail to get at the sense of something of interest. So this is actually the point. We do abstraction by hiding things, by ignoring things, actually. And at some point, something interesting might pop up, and then we can, yeah, see that. So actually what we do is we build models, and I want to build a very easy model together with you. Very simple thing. I want to make one specific type of abstraction. It's called data abstraction. And in data abstraction, our goal is actually to look at a certain context, situation, whatever, and try to get all the information that is important for us. On the next slide, we will present you actually a task, and the task is, what data of a student do we need in a student management system? There are thousands of features that are related to a person. So it can be medical data, it can be student data, it can be sociographical data, whatever. And so the question now is, how do we just get the important data that is needed for a student management system? And since all of you are enrolled in a student management system, just type into the chat what you think, what kind of data do we need when we design a student management system like TU Graz Online, for example? What data of a person is really relevant? Yeah, the name is definitely relevant. Date of birth, ID, student ID, sure. Matrikelnummer, record of studies, date of birth.
Maybe to add that we assume that we are a serious company and not like some American which are collect data. We do not
Yeah, we
want them to
collect data
collect.
just for we don't collect for the purpose of collection. We collect for
Yeah.
purpose of using this data actually.
Courses, yeah, of course, the address, ECTS, type of study.
Yeah, I mean, that sounds really good what you already did there.
The IBAN is interesting. I don't think we need the IBAN from students, do we?
I'm not
Except their tutors.
sure. Yeah, probably, but then it's not student management kind of lunchbox.
Yeah.
So I think we agree on some of the most basic things, which is the name, the address, matricle number, what course they are enrolled, what studies they are enrolled. So I think this is actually already a good abstraction of we need. By the way, due to the name discussion, I really like this, and names are a very cultural thing. And in other countries, you have, for example, just a first name. So you, this is something that happens in UI design often, that you have like first name, last name, but sometimes you just have a first name actually. And I have a really cool blog post. I will share this with you. Just, you don't have to read it. It's just for those people that are interested. It's called Falsehoods Programmers Believe About Names. And this is one of the best blog posts ever, because this, yeah, emphasize on especially these things that often happen when we think about names in a wrong way. And there are nice examples. It's a fun post, actually. If you have time after the lecture, read it. It's really interesting from a programmer perspective, what sometimes causes problems with names when developing a system. All right. Yeah, so I would say we have some good idea of what abstraction could be, and your task in the next assignments and also in the homework will be to reach a certain level of abstraction and to think about problems in such a way that you can abstract features out of it. The next thing that we want to do is decompose problems. Problem decomposition is something that is really important for us, because decomposition means we have a huge problem and we divide it into smaller solvable problems. This is called divide and conquer, Teile und Herrsche, which is like the heart of computer science and programming. And for this reason, I have something with me that I guess most of you know, at least.
Hopefully.
Hopefully.
Yeah. Even though it's a little bit older than most of us, maybe, but we should know it.
Yeah. Let's reveal it. Yeah. So I think most of you know it. And yeah, actually, David, you already had a Super Mario example, which I just realized actually.
Yeah.
We will do something cool now. We will decompose Super Mario now. And yeah, we will have a closer look at it. And first of all, we analyze the game elements. And I will show you why we do this actually.
Okay.
So, I mean, there are like thousands of versions of Super Mario. I'm mixing up completely because I couldn't find like just a good set of sprites for one Super Mario Online. So I actually took my favorite Super Mario, which is Super Mario Bros. 3, which is actually the best, I would say. And here, let's analyze the game elements actually. This is like a all the game sprites that we have actually. And yeah, we have different elements. We have like things to level up. We have things we can interact with. We have coins, which are something in between. We have enemies. Yeah, so different elements. And what I try to do is actually get all the elements out of it that share something common, like to reach some certain level of decomposition to abstract things, but also to decompose things. And if we go to the next slide, this might be a bit clearer. What I did actually is decompose different game elements actually and combine this a bit with abstraction. So on the one hand, we have Super Mario, which is like our avatar, and we can play with it. And I think we all agree that this is something different than, for example, the Goomba, which is an enemy. So we can interact with them, but we cannot play with them. We have power-ups like the flower. And what we also have are in the game interactable and non-interactable objects, in a sense that we can probably stand on them, but we cannot go into like we can go into the pipe, for example. So we have different types of game elements, and we have, for example, also collectible items, which would be the coin. Yeah, so when we decompose Super Mario, these are the elements that I actually thought of. There might be some more. If you think about it harder, then you came up with some different ideas. But okay, now we decompose them, and now if we think about how to actually make a Super Mario game, we have a playable avatar, and we want to give the avatar some basic functionalities. And what would you say? What functionalities should Mario have actually?
So this is really just for this playable character.
This is just for this playable character. Yeah, can jump. Okay, move, jump.
Yeah.
I think this is a really basic thing. So what we do is we narrow things down and go into solvable details. Yeah, collect things, run, jump, left, right, dance moves. So yeah, perfect. I mean, I think we all have a common sense of what Mario should do. I also wrote down a few things, like move an object in the two-dimensional space, which is a super fancy name for just like moving left and right and up and down. So it's just a movement actually. Running, yeah, and jumping could also be like, since it's two-dimensional. Increase coins. Check for collision. Collision detection is something really interesting because depending on how the collision takes place, actually, it makes a difference if I collide with an enemy like this or if I jump on it. So the way and the angle of the collision makes a huge difference in like in the game, but also in game development. And of course, which is also interesting, is the goal reached? So yeah, is the level over? And what we do now, we pick a very easy first approach to think about the increase coin thing and write like a function. And what functions are is something easy. Functions are a way to solve one sub-problem. And we will do this. In a very abstract way, we will go into C, and into the C programming language, we will talk a lot about functions. But now, for now on, we will just check the structure behind a function. And what we actually have here is on the left side, thanks, an identifier, which is nothing more than something that identifies what this is, the name of it. And then we have function arguments. So I think we all agree on, if we have a function that should increase points, we need some additional information. For example, what was the number of original points and how many points do I want to increase the original points. Yeah, and we can have, or we also have names for these function arguments called parameters. So we have a first parameter and obviously a second parameter. We can have function with no parameters. We can have function with n parameters, so like from 1 to an infinite amount of parameters. We can have everything. And the parameters are something that I give into the function from external, which is like some additional information that I probably might need. I want to stop here for a second and ask in the chat, is the idea of what a function is clear so far? Do you have some issues with that? David, did I miss something?
No, so maybe just the most important thing to understand functions is that you have this big problem of creating a Super Mario game, and you divide it into sub-problems until you're at the point where you can say, okay, I can now solve this problem. And one of these sub-problems maybe is then to increase the points if Mario jumps on a specific thing or it gets a coin. And the function then is used to, or is implementing this then, this functionality to increase the points. So functions are really very, very helpful, and you will use it in, I think, in every or most of the programming languages. And it's just to implement a sub-functionality of the whole program.
Right. Thanks for clarifying that again. So we're still in the decomposition thing. All right. Okay, but we can provide the function with additional information. For example, what we could also do is adding a data type. David talked about data types already. So if you can remember, we talked about there are different ways how we can present data and different ways how data can be represented. Like we have numbers, we have strings, which like Zeichenkette, these kind of things. And an integer means our original points can be just an integer number, also eine Ganzzahl. And this is like the idea of points. And actually, that's the idea of the function. And this function needs some implementation. So the implementation is the code that actually runs behind the function. And the cool thing is, this is called function body, and there you have the implementation. So everything you do in this function belongs in the function body. The function is quite easy because it does nothing more than saying the original points should be increased by the additional points. So original points equals original points plus additional points. I think this shouldn't be really something new at that point.
But I have a question, Alex. Why can I just don't write original points plus additional points?
You can do this actually, but if you do this, you will have a calculation, but you won't store it somewhere. So by saying original points plus additional points, you calculate them, and then you have to store them at a certain spot. Yeah. So actually, the right part is then written into the left part. So you write the original point, the result.
Yeah, the result of this is then written into the left part of this assign symbol. Yeah.
Matt the Duck wrote especially the right terminology, therefore. So the assignment is from right to left and not from left to right. So the right part comes to the left part. And I was wondering if this would ask someone in the chat, this plus equal thing would also work. So I just put it in the chat. You could also write original points plus equals additional points in C, for example. So there are some programming language that support these features. So I think most of them will do that. So this is like a short form for the same thing. This is probably, especially at the beginning, more readable, but it's actually the same. Okay, this is cool, but this function now has a huge problem because it does something. But when we call this function, when like from outside, we call this function and say, okay, Mario collected a coin, and let's increase the points of I don't know, from 5 to 6. We can do this, but when we do this here, it's just within the scope, just within the function, and we have to somehow bring this outside of the function as well. And this is when we need to return something. The idea is quite simple. We do calculations, and we want to return this value to the function which is calling actually this function. And this works like that. We have, again, a type. This is called a return type. And this says, when the function is done, we will return you again an integer. And this is clear because an integer plus an integer is an integer again. And so increase points will just return an integer. And we will do this lots of times to return functions or to return a value within a function, because we need this like most of the times. There are also other ways to shift around this in C, but we will talk about that later in the semester. This is not important yet. Felix just mentioned that the semicolon is missing. If this would be C, yes. I assume this is a pseudo language which is related to C, but which is not C probably. So yeah, depending on if you interpret this now as C, then yeah. If you interpret it as something different, then it doesn't have to be there. And yeah, actually, Miras mentioned a good point. I haven't realized it. Yeah, you're completely right. We should return the original points and not increase points.
So this is the function we return.
Yeah,
that's
yeah.
We shouldn't do that now.
We shouldn't do that.
The original parts.
Yeah, thanks for mentioning that. I went over the slides 100 times, but haven't mentioned that. Okay, cool. Thanks. All right. Yeah, so maybe think of a move function, very basic, just how would a move function looks like. So basically, we have to think about different directions where Mario can move. So to make it really simple, again in the chat, what would be your approach to move the character? So very basic. So just like in words, not in code. Yeah. That's a good point. So actually, we have to consider X and Y coordinates, because Mario can go in different directions. And we also should consider if he can go to the back as well. Because most of the ideas here assume that Mario just goes, like, increases in terms of going to the front or up. But we also have to consider that he could probably, depending on what we want to have, go back. But I think the approach of, depending in which direction he's going, adding a value or decreasing a value might be a good approach to move Mario in a certain direction. So actually, that's the point. We need probably 4 functions, or at least we have 4 possibilities to move Mario. And whenever you press a key, for example, something will change in the coordinates. If you go up, the y coordinate or the y value of Mario will be increased, or if you move to the front, same with the x. And if you go back, then it's decreased, or if you go down, it's decreased as well. So this is actually the idea of the movement function of Mario.
And that's
Okay.
also the reason maybe that you need to learn the basics about linear algebra, because you need this kind of stuff to move characters in a room, maybe in a 2D or maybe in a 3D room. So you need the basics of that, and that's why you learn it in the first semester.
That's right. So when you want to be a game engineer, then you should definitely
Yeah.
be good in linear algebra.
I hope we did not crash now any dreams. So in
All
fact,
right.
some points or some stuff in programming is related to maths.
Yeah,
It is like that, yeah.
it is like that. That's also the reason why some people study both.
Yeah.
Okay, but
Great.
David, I think you brought
Yeah.
something with you, and you want to
Yeah.
show us something.
I brought or have an experiment with you, and I will now change it to here, go a little bit back. And Alex, I really like to see you, but for a
No
few
worries.
minutes, I want to disguise you a little bit and that you can see only me. And I have brought my phone book. I hope any one of you uh, know it. So it's the old way to store neighbors' telephone numbers. But I will show you a little bit in this, or I will give you an idea what an algorithm could be using this phone book. So let's say we want to, or I want to give a call to a hypothetical person called Alexander Stone. So that's really, uh, yeah, I just came up this idea. And I know his name is in the phone book. So at first, okay, I want you to look at the first page. It's not here. Go to the second page. Go to the next page until I find the name. So the last name is Stone. S is, yeah, in the alphabet, I would say after half of it. So it might take some time to get to this name. But in general, this is already an algorithm I showed you now. So I start from the beginning, page by page. Is this algorithm correct? And correct means in this case, do I find the name? Maybe you can write it in the chat. Will I find person I want to give a call? Yes. So is it correct? I will come to any point where I find the correct number, the name, and then I will see the telephone number. Hopefully there are many of them, and then I find the correct number. So it's correct. But is it efficient to do this? What would you say? Efficient or effizient in German? So, and it, yeah, are there too many steps necessary? Yeah, so it's not very efficient because I have to go through all my pages, and this will take very long to find the correct number. So let's say one of this looking at the next page is one step. So maybe it takes me, I don't know, 200 steps to find the correct name. Is there any better way to do it? Do you have any suggestions? How can we do it better? So not having, I don't know, 200 steps, maybe we can make it better. Yeah, Control F. Control F would be great to have here, but it's hard. Um, there are, of course. other steps or other things. I also read use an index, also very interesting. We'll come to that. It's already sorted. That's very interesting that you write it because um, if we do not know or if it's not sorted, we have to go maybe through all pages because they are randomly inside. But as we know these phone books are sorted, we can make better. We can find a better approach to find our name. So another approach would be, for example, to skip every second page and yeah, go through it. And if we find the name, we are done. Or if we are if we've gone too far, we can just go one back, and then we find the name too. So this again would be correct. It would be more efficient than before because we only go on every second page. So maybe we only need 100 steps, but it's not that efficient again. So that could be more improved. So I already saw it in the chat, the so-called binary search is very efficient. So we know we want to find the name um, Stone in the last name. Okay, so I start in the middle, somewhere in the middle, and then I look, okay, is the name here? Do I find the name here? No, I can't find the name here. Okay, are the current names also the name, so the first character, is it later in the alphabet or before? If it's later, in this case, I am at K. So we can really do not use this first half of the book and only use the second half of the book. And then I can do the same, okay? Go into the middle of all of my phone book again, and I'm now at W. So I've gone a little bit too far. I'm now at W. So remove the other side. Not interesting. So I had two steps now, and my phone book is very small. And I can do it again. I am now at R. So I'm very close to S. Remove the side which I don't know or which I don't need anymore. And then I can do this again and again. But now I already have, so I had 3 steps, I think. And I only have 10, maybe 15 pages left. So this is very, very efficient. And is it correct also? So if I do it one or maybe 2 times, then I come to the page where the name is. Is this correct again? Do I find the correct name? Yes, it is correct. And it's way more efficient than before because I only, yeah, I think there are 4 pieces on the floor. So I only need 4 steps for that. So Alex, I will now, yeah, I want to see you again. Here.
I'm
Did you
super
enjoy?
I'm super happy that I was not in the picture because I almost broke because the responses in the chat were awesome.
Yeah, that's what I was hoping for. But I think it's a very nice or a very cool way to give you understanding how algorithms work. So there are different approaches. Some or most of them can be correct, but they really depend or they are divided into the efficiency. So some are very efficient, some are less efficient. And this is a perfect example. So I really love this example. And I talked to Alex months ago that I want to present this.
Yeah, you shouldn't do this with all of your books now. So
No,
please be aware of
this is
that.
really, I do not need this phone book anymore. Okay, so let's write this, what I have done, into pseudocode. So we have my name, which is the last name of Alex Stone in this case. At first, I looked at the middle page of my current phone book. So at the page that is most in the middle of all. And then if I found the name on the page, I'm already done. But if I do not find the name, I choose a new search space. So just removing the part which I do not need anymore. And this can be if the name is earlier than the current names, then use the left side and remove the right side. And if the name is later than the current names, use the right side and remove the left side. And then just go back to number one and again look at the middle of all these pages of the phone book. And this is then a loop until I've found the name on the page and then I'm finished. So this is a very basic pseudocode, but I think you can get a good overview how it works. Alex also showed you a flowchart last time, and I will add on this a little bit because also this problem can be displayed as a flowchart. So we start, we look at the middle page of the current phone book, then is the name on the current page? If yes, we are finished. If no, then you have another consideration. Is the name earlier in the alphabet than the current names? If yes, divide the phone book and only keep the left side. If no, divide the phone book and only keep the right side. And then go back and look again in the middle of your current phone book. So again, very basic example of flowchart of the same thing. Um, are there any questions to this, Alex?
Not really. I think this is
Comments,
quite
but
clear.
not questions.
Many comments, but no questions. Yeah.
I hope the comments are funny and they're laughing a little bit about me.
Yeah, they feel very sorry about the phone book, but besides that, I think it's clear.
Yeah, but I didn't pay for it. It was Restware. Yeah.
That's good.
Okay, another very interesting algorithm. Maybe some of you have already really seen, because they watch maybe Big Bang Theory, is the friendship algorithm. So in this case, Sheldon wants to meet friends. He's not social, not that well educated, I would say, and wants to create an algorithm how to befriend with another person. And this was, in fact, really his algorithm he created. And it's very interesting and it's true. That's the sad thing. It's really true how you can make friends. So the first thing is, okay, place a phone call, call the person. Um, then if it is home or if it enters the phone call, okay. If no, then leave a message, wait for a call back. So wait that he or she call back. If he or she is at home, then would you like to share a meal together? And if you want to call, or if you wait for the callback, then there is a loop or a condition going to, again, would you like to share a meal together? Waiting for the response. If you want to share a meal together, then dine together and begin friendship would be the best case. But if he or she do not want to share a meal, then maybe you want to have something to drink together. Again, watch or wait for the response. If yes, then you can choose between tea, coffee, and so on, and then begin the friendship. Or if not, that would be tricky then because the other person do not want to share a meal or something to drink. And then Sheldon has the idea to tell that the person should tell about interest of him. And if they share the interest, then they do it together and begin a friendship again. But as some of you might know um, this episode, um, they do not really share many interests, and they are caught there in a so-called loop because Sheldon always asks, "Okay, tell me another interest. Tell me another interest. I don't like this interest. Tell me another interest." And then I think it's Howard which introduced here a loop counter, meaning that if you have more than 6 interests already told, then choose the, yeah, the interests which are the most suitable for you, then begin friendship again. So this is very interesting because um, you see here in a basic flow chart again conditions where you have a yes, no, but you also can see here, I will zoom a little bit into it, you can see here a loop. So you have this counter variable, you set this counter variable to 0, then tell about the interest. Do I share this interest? No, then I increase the counter. If the counter is higher than 6, then okay, I take one of them. But if no, then I'm here in a loop, and this loop um, will go through at most 6 times, and then I will take the interests which are the most suitable for me. And I will just give you also the pseudocode for that. So this could be, for example, set n to 0, then ask for an interest. Then if me not share this interest, or if I do not share this interest, increase the counter. I've now switched it here. So if n, so this counter is smaller or equal to 6, then go to line 2 again here and ask for another interest. Else, so if it's higher than 6, choose the best interest. And also this else here is the else statement of this if here. So ask for interest. And if you do not share this interest, then you can come into this part. But if you share the interest, you will come directly into the else path and choose this interest. So this would then be this yes here. Is this clear, Alex?
I think this is very clear. And if you have questions, please put it in the chat. And I was about to add, you won't see go to too much in our course, but in that case, this is actually a simple way to represent this. And I was actually waiting for someone mentioning that GoTo is not
Yeah,
good.
it's usual in pseudocode
Yeah,
that you jump to a line, but we in our course in C, there's also a statement called goto, but you're not allowed to use it because
right.
it destroys your structure of the program. But in pseudocode is yeah, commonly used for that.
Yeah. So
Okay,
if I think there are no questions, the code fits or matches with what you have on the picture. So I think this is quite understandable.
perfect, perfect. Okay, so let's go. I think it's again something with algorithms and data types in
Right.
memory. And Alex also today talked at the functions about data types. So we have integers, and I also want to give you a short overview again. We have a Boolean variable, which are just one or zero, or yes or no. We have characters, integers, longs, which are just integers with where you can store higher numbers, floats, so floating point numbers, or Kommazahlen in German. Doubles are just floats with a higher precision, so with more bytes, which you can store then the data. And we have strings, but at strings, we have the problem that they have variable size. So most of the strings, or if you have a word or a sentence, they are depending on their size and they are varying in their size. So how many bytes do strings have? Any guesses in the chat, maybe? Is it possible to store it? Because every other data type has a fixed size. Do we also have it for strings? By the way, yeah, I've also read it in the chat. 1 byte, 4 bytes. So this is the common implementation in many programming languages, in many operating systems that, for example, integer takes 4 bytes, a long takes 8 bytes. So it's implemented like this. And yeah, I've read it already. It depends on the number of characters, of course. So how does it look in the memory? I showed you last time this memory, and here you have just memory locations where you can store data, where these binary numbers are in each of the cells. So there are just binary numbers inside. So let's look at the first binary number here. And if we write it in decimal, it's 72. So 72, we are talking about strings. What could be 72? Let's look at the ASCII table. Okay, 72 is an H. Let's look at the second one. The second bits can be interpreted as decimal 101 or as character E. Then we have another bit representation, decimal 108, and the ASCII character is L. Then we have the same bits in the next memory location, and then we have another bit, or another bit, 8 bits, which correspond to the ASCII character O. So we found our first string in the memory. It's just hello. But as you can see, we now know how strings work. So strings are really just continuous characters in memory, and all these continuous values or storage in the memory are called arrays. So every time if you have values which belong together in some kind, they are called arrays. In this case, we had this string of hello, and each character is 1 byte. And then if we have these um, these 5 characters, so the E after the H, the L and the O, then we can have a string. So in such an array, we have values, in this case, the characters, but the characters are, of course, just a representation of binary numbers. And we have an index of arrays. So we can say at this string at the index 2 is an L. But this index starts with 0. As most of the time in computer science, we start with 0. So the 5th character has the index 4. That's a common problem in the beginning. So please, if you're writing code, always remember the index starts with 0. So the first character is 0. The second character is index 1, and so on. But now you have the problem, when does the string end? So when is the end of a string reached? And the end is defined in general by a so-called null byte, which is just another byte where only stored zeros. So 8 times zeros. This defines then the end of a string. And then I know, okay, here ends my string, which also means that if I want to write hello of 5 characters, I need 6 bytes for that, because for each of the characters. And then I need another byte for this null byte, which then defines where the string ends. So arrays, I talked a little bit about arrays here now, and arrays are continuous values or continuous values in the memory. But we are not only bind to characters, we can store any data type in arrays. So for example, integers. We can store here these numbers into an array and say, okay, these are, for example, maybe the points of students in this semester. So they belong somehow together. and we can store in this array the points of students. Again, they have an index starting again with 0, and in the code, so this is then really C code in this case, we can define an array with the data type and then say, okay, this is the variable name, this is the size. Then I can say, for example, array at the position 0 at the index. So really this one here is 32. So I can assign a value now. And then I can make an if statement, for example, and say, okay, is array at the position at the index 0 equal to 42? Then print something. But we will go into more detail, I think, next time. So in 3 weeks, beginning at the first November lecture, where we show you all the C stuff, or everything we mentioned now, how it is done in C also. And then, yeah, if you have arrays, you can search in these arrays. So in already sorted arrays. But the problem is that the CPU only can look at one memory location at a time. So for us, it's really like this. It can be seen like this array, but the CPU sees it like this. So it's hidden and it can only view at one location at a time. So if I want to see in this array at the index 0, I will just can open this door maybe. If I want to have the index 0, 1, 2, 3, 4, 5, I can view at this location and see here this number, or at the index 2, I can view at this number. So for the CPU, you can only watch one number in an array at a time. And of course, so for us, searching here in this array, the number 32 is obviously easy because we can just point at it. But it looks, for the CPU, looks really like this, and you have to search through it, like we did in, with my phone book here, which is on the floor. Um, So we already did this. We already searched something in an array. The array was, in this case, the phone book. It had, in this case, also names in it, but we also used a linear search. So start from the beginning and going through all the indexes, going through all values to find what I want to find. So this was the linear search. And we used the binary search where I started in the middle and then split it and throw the other half away. So we already used our first searching algorithm by also destroying this phone book. But yeah, maybe now it's a little bit clearer how this can be, how this works. And yeah, do you have any questions, or are there any questions, Alex? I saw you are very busy.
One question that came just up is why we start counting at 0. It's like it's a convention in computer science. You always start with 0, so you don't start with 1. You start with 0. And by convention in all programming, nearly all programming language, it's like that, or in computer science. So you always start with 0, 1, 2. So it's very simple. You just, in computer science, 0, and then you're perfectly fine.
Yep.
I had this teacher in my school who thought he's very funny, and he always told us this joke. And I'm struggling with myself if I should tell this joke because it's not really funny, but I have to do this because
we are also teachers, so
yeah, exactly. So we can also
it's
be
okay.
a bit weird. So imagine this guy has 2 suitcases and he's like on a train, and he checks everything if he have all his belongings, so phone, wallet, bags, and then he knows that he has 2 bags with him, and so he starts counting them, and then he's like, okay, 0, 1, and then I think I have 2 bags with me, right? And then he starts again, 0, 1, and then he's searching for his second bag actually. But
that's really not that funny.
yeah, as I told you, weird guy, but yeah, I mean, this was
But it's fine.
it was in a Berufsschule, so maybe it was the humor of our, or I mean, I was 15 and I was like very childish, so it was perfectly fine.
Another question in the chat was, so a binary search would be not able to find or to search a number in an array. No, so all this, so the linear search and the binary search are able to find numbers. They are only different. They are only different in the way how they approach it. So the linear search start at the first one, then go to the second one, go to the third one, and so on. And the binary search really starts in the middle and split the field which I want to search from now on. So as I did it with the Phonebook, throw the other non-search space away, just use the remaining pages, then look in the middle again and throw the thing away I do not need until I found it. So all of these algorithms have or are correct, so they find the name, but they have different approaches to do so. Some of them are less efficient, some of them are more efficient. In this case, linear search is less efficient and binary search is very efficient. Any other questions there? I think, Alex, you have something left now for the remaining 10 minutes.
Yes.
Does this work in 10 minutes?
Perfect. That's awesome.
Yeah, perfect.
We already had a lot of things, and now I just want to go over pattern recognition in a very easy and basic way, since you had a lot of information already today. But give me a few minutes to make you clear what pattern recognition actually is, because it can be also a huge thing. I have a sequence of numbers with me. Your task, what is the pattern?
Marcus was the fastest.
Yeah, well done. Yeah, +3. Okay, you seem to have a good and easy time figuring out what the pattern here actually is. And yeah, this is actually what pattern recognition is about. We try to find patterns in different kinds of data actually, or in behavior. And this is what we try to do in computer science actually. And we know pattern recognition also from other fields, and I have something that you might know. I'm not sure if it's like a age thing, but I think most of you could probably know what I also have with me. David, let's show what we have with us.
Oh, yeah. Also old school. Today we are really old school.
Yeah, it's a bit of old school, but I think most of you know this. Yeah, Minesweeper. This game was installed, and honestly, I had no idea about the game. I just clicked around until I figured out years later that there is actually a logic behind that. So
Me too. So as a kid, I was
it
just
was never fun.
clicking around.
Yeah.
I never get it. Yeah.
No, and it was never fun. Yeah, same for me. It took me a while. Actually, just a couple of years ago, I understood how it actually is. And it's pattern recognition, actually, what you do. And on the next slide, yeah, I have some basic patterns with me. So what is actually the idea of it? The idea is you click on the fields and try to reveal no mines actually. So that's the goal of the overall game. So you shouldn't click on a mine. And there are some certain patterns. For example, if you like on the left picture, you can see, okay, there is a 1, and above the 1 there is this red flaggy thing. And so you tried to or you marked this field as a potential mine. And now the question, why? Any thoughts in the chat? So maybe we have an aha moment for many people now. Maybe someone knows why this could be marked as a potential mine. Any ideas on that?
So you talk about this
Yeah,
one here.
right.
Yeah.
Okay, there's 2 bombs near, left one is wrong. Okay. Wow, yeah. I mean, these are really good descriptions and probably better than I could explain it. So actually, what we do is, from a given number, we check the neighborhood and see if there's potentially a mine. And for example, for this one here on the left, I don't have a cursor, so yeah, thanks. It says, okay, there should be a mine in the neighborhood, and there's just one. And when you go to the right set 2, in it, like the one, sorry, the 2 between the ones.
This one.
Right. Thank you so much.
Yeah.
Then it says, okay, in the neighborhood there should be 2 mines actually. And so a pattern here could be that both red flagged fields could be the mines, since 1 and 1 says, okay, there's just one mine in the close area, like in the neighborhood, and the 2 says, okay, there is 2, and these are potentially these 2 red flags. Yeah, so this is some possible pattern here. But you just can't be sure if you click on it, and if nothing happens, then you're good. If it's exploding, then you're not good.
But this here is of this picture, it's wrong, right? Because here are 2 and 2, so here
Yeah.
are also 2, and there's just 1 in the neighborhood. So, for example, here or here also should be
Yeah.
a mine.
Right. Right. But it doesn't mean that it's like, yeah, I just flagged something. Let's call it like that. But yeah, here are also some patterns that we encounter, and yeah, finding patterns will be something that we will do over the semester also in follow-up lecture units to actually get a sense on how to do this. All right, I think we can conclude now.
Yeah.
What happened today? We talked a lot about computational thinking, and actually we had a 90 minutes introduction into that, or accelerated introduction. So we talked about these 4 skills: abstraction, decomposition, algorithms in detail, pattern recognition, just that you get a first sense of what it is. And David, you introduced something really cool new. What did you introduce?
The arrays, you mean?
Yeah.
Yeah. So a collection of values of the same data type, continuously stored, so nacheinander in German, in the memory, and by index, then you can address some of these values. You can go to the first, to the zeroth, to the third, and so on, and then you can interact with it. And also strings, as we have seen, are a collection or an array of characters. And I think you introduced functions.
And I introduced functions, which we had a close look in decomposition as a way to break a large problem into sub-problems that are solvable actually. And as you can probably remember from what I told you, a function has an identifier and a list of parameters, and then actually there is a function body where the magic happens. And you will learn about these things in detail, and you will practice them, and now you get a first sense of what it is actually.
So, and of course, you have now, as I already said, 2 weeks time. So please use this time. Of course, you can chill a little bit, but use also this time to practice. Also start a little bit practicing C, because then after the holidays, we will, yeah, go into C. We will show you all what we have now talked about in general. We will show it in C.
Right.
And Niki and Julia also have shown some things. So please be prepared and yeah, do your homework, especially task homework.
Yep.
Alex,
We
what do
should
we do now?
we should mention that as well. Yeah. So there is a
Yeah,
homework this week again. So most of you, almost 600 people, completed homework 1. Well done. And now we will give you a first idea of what homework 2 is about. But we will actually send it out or activate it by tomorrow, because there are still a few things that we have to clarify in the document. But just that you get a sense what homework 2 is about, and we will announce that now later on in Discord when we have it online. So actually, it's about problems, and we spend a lot of time with problems now already. And we have prepared 3 problems for you, and these are actually cool problems. The first is, for example, a theater reservation system, and your task is to write in a written language, not in a programming language, in a written language, like pseudocode or just like instructions in prose or whatever, work on these problems. Here, for example, you have a cinema or like a theater hall, and there are some seats that are reserved, some are premium seats, some are regular seats. And what you should do now is write a few functions. And as I said, no programming is required. This is really just that you get a sense on how to formulate probably such problem plans or how you would approach this. And therefore, you have several tasks. For each of the problem, there are 3 tasks. For example, you want to buy a ticket, and how do you do the calculation? Or you want to figure out how many seats are available, just in text. How would you actually solve this problem without any programming, as I said? Then we have a playlist for songs, and you should figure out that it's a good balance between pop songs and rock songs, for example, or other songs as well. And yeah, should do a few things with that. And the third one, it's a pizza delivery service, where you should find a way to deliver pizza in a fair way, which means the guy who ordered first should get the first one, and yeah, things like that. That's it actually. These are the 3 problems. We skipped the problem 4.
okay.
Right, and we will send this out by tomorrow, exactly,
Yeah,
and then you can start with that. And no programming, please, no programming. It's really just in plain language.
exactly. So more details will come, or we will announce
Announce in Discord.
maybe on Discord. Yeah. So tomorrow you will get the homework. So this is really the homework too. Alex designed it. That's why we now show it to you. So
Right.
yeah, Michi and Julia now have more time to give you some insights in what they have prepared today. I'm very interested. haven't seen it until now. Hopefully, or not hopefully, I'm quite sure that it would be very interesting too.
Definitely.
So we are done now.
We're
Yeah.
done now, yeah. 2 minutes
Thanks
over,
again.
but I think we're good. Yeah,
Thanks
thanks for
again.
being.
Yeah. Hope it was interesting for you. Next time we will go then more into C programming. So this is our last general conceptual thinking and computational thinking lecture. So yeah, thank you. You have now again around about 15 minutes break, and then Michi Judah will come back to you.
Right. Okay, then see you soon. Goodbye.
Bye.